So now for the tangent. So a tangent function looks like this. Its asymptotes are at pi over 2 and negative pi over 2, and then you just add multiples of pi to those, add or subtract. Integer multiples. And so what we do here is notice that this branch that goes through the origin, we call these separate pieces branches. So this branch that goes through the origin is 1 to 1. But if I tried to go on to another one, if I tried to include part of this one, it would no longer be 1 to 1. So I just use this one piece here that goes through the origin. Okay. So that's for x between negative pi over 2 and pi over 2. So we get f of x equals tangent x with the domain being negative pi over 2 to pi over 2, the restricted domain. The range is still all real numbers. Then we do the inverse. The vertical asymptotes become horizontal asymptotes. The y-axis becomes the x-axis, because remember, you're just switching x and y coordinates. And instead of getting the asymptotes x equals negative pi over 2, you get y equals negative pi over 2, right? And x equals pi over 2 becomes y equals pi over 2. It still goes through the origin, because switching 0, 0 gives you 0, 0. And if you reflect this across the line, diagonal line, it looks like this. Okay, so that's what the inverse tangent looks like. It's kind of a nice function, actually. So that's called the arctangent of x. The domain is all real numbers, and the range is negative pi over 2 to pi over 2, not including the endpoints. Well, there are no endpoints, they're asymptotes. So not including negative pi over 2 or pi over 2, because they're asymptotes. Okay, so that's that one. Now we need to worry about secant, cosecant, and cotangent.